Hi guys, so welcome to another video. So this video has been a long time coming. Today we're going to be looking at Unraid 6.12. Now as of making this video, the stable version hasn't quite been released yet. I wouldn't be surprised by the time I upload this video that isn't the case and the stable version's available. Now I'm making this video using the version 6.12 RC5 and I've waited a while to make this video because often during the RC development additional features get put in, so I wanted to make the video as close to the stable version as possible, and to be honest I'm glad I've done that because there's some quite cool things that came into the RC5 that weren't in previous versions. Okay, so the first thing to do I think is to go across to my test server and we'll take a look at the update process from Unraid 6.11 to Unraid 6.12. Now the first thing I like to do before doing any update is to update everything that's on the server already. And although it's not actually necessary to do, I like to update the Docker containers first. So I go across to the Docker tab and click check for updates. And if any updates are available, for me there aren't, then I just update all of the containers. Now more importantly is to update the plugins before we make an update. At the top here we can click check for updates and we can see two of my plugins here require updates, so I'm going to click on update all plugins. Okay, so with all of the plugins now updated, I always like to do a bit of house cleaning at this sort of time and remove any plugins I no longer need. Now I don't have an AMD GPU in this server anymore, so I may as well remove this. And I don't need the Wake on LAN plugin, so I'm going to remove that as well. Now as you can see at the bottom here, I've got two ZFS plugins already installed. Now as you know, Unraid 6.12 has full ZFS support, so I'm not going to actually need these plugins. Now you might be tempted to remove any ZFS plugins before updating, but I really recommend not to, because if you've installed ZFS plugins on your server, well they're probably in use right now. And the update process will remove any incompatible ZFS plugins anyway, so let's let it do its job. And also there's another plugin that will be automatically removed. Also after updating we'll notice this plugin here will have been removed because this plugin's only for Unraid 6.11, which fixed an issue where you couldn't see on some Docker containers sometimes if there was an update available, and this patch fixed that. Okay, so why am I mentioning this if it's only needed in 6.11 and it's automatically removed? Well, I'm mentioning it because some people may have not used the patch because they manually set up a script to do what this patch does. So if you're one of those people, then please make sure to remove the script before updating. Okay, so with that done, let's go across to the main tab here, click onto Flash and click Flash Backup to make a complete backup of the Unraid flash drive how it is now. Now this can take a little while, so just be patient. Okay, so once you've downloaded your flash backup, we can now go across and update the OS. And to do that we need to go to Tools here, and of course we want to click onto Update OS here, and on the update page here, if it doesn't say there's a newer version available, just click on check for updates and it will do a check. And at the moment on what's called the stable branch, Unraid 6.12 isn't available, but if you wanted to try out Unraid 6.12 before it goes stable, then just switch the branch here from stable onto next, and we can see now that Unraid 6.12.0 RC5, well that is available to install. But please do remember that this isn't the stable version, so if your server's mission critical, I'd recommend not installing Unraid 6.12 until it's available here on the stable channel. But for me, I'm quite happy to install RC5, so I'm going to click onto install here. Now you'll notice at the bottom there's a button that says close. Make sure not to actually click this, we need to wait for the whole process to be finished, after which this button here will change to done. Okay, so the button says done, so let's click onto that now. And if I click back onto the main tab here now, we can see here it tells us to reboot to upgrade the OS. Now some of you might find a little pop-up window on the right hand side saying that there's a process running in the background. If you see that, make sure to wait until it says it's safe to reboot. Okay, so I'm not actually going to reboot right now. What I'm going to do is I'm going to look at a few things in Unraid 6.11.5 so we can compare it when we reboot into 6.12. Now the first thing I'm going to do is I'm going to go onto the dashboard here, and you can see here there's little arrows where I can minimize the tiles, and I can move things up and down, but I can't move them left and right. So when we boot into Unraid 6.12, we'll see some nice changes on the dashboard. Now let's go and have a look at shares now, and if we look here under cache, we can see prefer cache, because this app data, whenever it can, will be on the cache drive. The data drive here is set to cache yes, which means new files will be put onto the cache and then Mover will move it onto the array. Let's take a look at the data here, and we can see in 6.11 that this is the structure for how files are actually placed in Unraid, whether they go onto the cache first, whether they go straight to the array, and basically how Mover works. Well, in 6.12 all of this has been changed, so we'll be looking at that in a moment. And also on the shares, if we look on the right hand side here, if we want to look at the files, our view button is right over here, and I've always found it difficult to get to it, especially if there's something halfway down, and this we'll find is also something that's changed in 6.12. Okay, so I'm almost ready to reboot now. But first let's just see what the kernel version is in 6.11. We can see here it's Linux 5.19.17. Now while I'm just up here, I don't have any notifications at the moment, but the way notifications are handled in 6.12 are slightly different. So just remember what this looks like up here. Now let's quickly have a look at what Docker version we're running in 6.11. So Docker version is 20.10.21. And let's have a look at the VM manager. The libvirt version is 8.7.0 and QEMU is 7.1.0. Now obviously the QEMU version, this relates to when we make a VM to the machine type, when we see like 7.1 after the 440FX or the 7.1 after Q35. And whilst we're here in the VM section, if we scroll down here and we look at the network models available, in 6.11 there's only 4 that we can select from, but in 6.12 there's actually 1 more. Okay, so I think that's enough looking at 6.11. Let's reboot and go into 6.12. Okay, so let's log back in. Now this server isn't set to automatically restart, so I'm going to start it up now. Now the first thing I'm going to bring your attention to is, if you remember, I said how notifications are handled are slightly different. If we look in the top right hand corner now, we've got this little bell, and if I click onto it, I can see the alerts, warnings and notices. So on notices, I'm going to click onto view, and we can see there's a new version of Nerd Tools that's available, which actually came out after I updated all of the plugins before I did the OS update. And if I go to alerts and click view here, we can see here that the ZFS companion plugin was removed as it's incompatible with this version of Unraid. So that's just telling us that that plugin was removed due to incompatibility. Now let's go to the plugins tab here again. So I'll quickly update this plugin, and scrolling down to the bottom here, we can see here, yes, the ZFS companion plugin has been removed, but also we can actually see the ZFS plugin itself that was removed as well. Okay, so let's go back to the main tab. Now I'm sure everyone's wanting to see the native ZFS on Unraid, but let's wait a moment. First let's go to the dashboard here, and if you remember before, we could just come here and drag things around. But now what we have to do is click onto this little padlock at the top here, and we can unlock the dashboard, and then that allows us to drag things and put them where we want. So it's really nice that we can fully customize the dashboard now. And for example, if I didn't want this tile here, I can just close the whole tile and totally get rid of it. And once I've got everything how I want, I can just click onto the lock, and then everything's locked in so we can't accidentally move things around. Now if I go to the Docker page, the padlock's here as well. So if I unlock this, then I can move the containers around into the order that I want them. And that's also the same on the VMs tab, but I don't have any VMs actually installed on this server, but the process would be the same, unlocking it and moving them into the order that we want. Okay, so now let's have a look at the Linux kernel version. And we can see now it's Linux 6.1.27. Now I'm sure people who have Arc GPUs are wishing that we had the 6.2 kernel, which gives official support for Arc GPUs for things like transcoding in Unraid. But remember, in this video I'm using RC5, so I'm not using the full stable version. Now maybe 6.2 will come in the stable version, I don't know for sure, but there's definitely a chance, I think, because 6.2 is now officially stable, even though it's not an LTS kernel. And also I think last month in April, ZFS has support for kernel 6.2 as well, because obviously that's very important that Unraid now only use kernels that have full ZFS support. So you never know, in the first stable version we might have full support for Arc GPUs. Let's hope so. And let's go across to settings, Docker, and we can see Docker is 20.10.23, and VMs, it's still libvirt version 8.7.0 and QEMU 7.1.0, so no changes there. But if you remember, we can see here if we scroll down, for virtual NICs, we've now got VirtIONet, which is default, VirtIO E1000, this is the new one here, RTL8139, an older networking card, but great if you want to run things like I do. I know it's a little bit sad, things like Windows 98 and Windows 95. And obviously we've got VMXNet 3 still, so one extra virtual network card here. And also there's been some changes made under the hood. There's been an update in the memory backup processing for VirtIOFS, so there's no kind of editing of templates if we've got an existing VM. That's all done automatically now, which is nice. And let's have a look on what we've got on this list here. Oh yeah, we can add serial numbers now to drives, which is quite cool. So why would we want a serial number? Well, the VDisk can actually appear as it's got a real serial number like a real disk would have, so that's quite nice. Being able to do this rather than having to edit XML is a real nice touch. It would have certainly made it easier for me to make my April Fool's Day video a couple of years ago, where I created a VM of an Unraid server with a 2 petabyte array. Okay, so as Phil doesn't take very long to have his lunch, let's add a bunch of them to the array now. Okay, I've got to be quick. Well, there's the first 10. That's brought it to a petabyte. It was fun making that video. Certainly been a lot easier if I could have actually added them straight into the template. Okay, we talked about the lock to actually sort the VMs in what order they want to be earlier. Oh, but what I haven't mentioned is copy and paste is now an option for virtual consoles, so we can enable that in VNC, etc. And so in the VM section, nothing else really very interesting. We got OVMF stable 202302 and everything else really just bug fixes. Okay, so moving on, let's click onto the main tab here. Okay, so I think it's the perfect time now to move on and take a look at ZFS in Unraid. Well, we can see here I've only got one disk in the actual main array. I've got a ButterFS drive here, which is my cache, and I've got some unassigned disks here, which we can use to make some ZFS pools. Now, one thing I've just noticed is I'd pre-cleared this disk earlier, as this disk I'm going to pop into the array, but it doesn't actually say that it's been pre-cleared. So just a little tip, if you click onto Start Pre-Clear and you have a disk that's already been pre-cleared, under Operation, just click Verify Signature and click Start. And then after a couple of seconds, if it can see the signature on the actual disk, then it will tell us the disk is pre-cleared. Great. Okay, so what I'm going to do now is I'm going to stop the array. And with the array stopped, that's going to allow us to make changes to the configuration. So we can make our first Z pool. Now you can see I've got 3 4 terabyte drives here, which I'm going to make a Z pool with. So what I'm going to do is I'm going to go up here and then click on to Add Pool here. And we need to say how many drives we want inside the pool. I've got those 3 4 terabytes, so obviously I'm going to choose 3. And now it's very important, you've got to give it a cool name. You can't just have like a boring name. What shall I call it? I think Cyberflux for this one. Okay, so now we have to assign those drives. Now with a Z pool, it's important that all the drives are the same size. Well, actually they don't actually have to be the same size, but the problem with using mixed size drives is the pool is actually limited to the actual size of the smallest disk. So what I mean, at the moment I've got 3 times 4 terabyte drives, so my smallest disk is 4 terabytes. And in ZFS, the usable space formula for single parity or RAID Z1 is the smallest drive size multiplied by the number of drives minus 1. So for me, obviously the smallest drive is 4 terabytes. I've got 3 drives, so 3 drives minus 1 is 2. So 2 times 4 terabytes will give me 8 terabytes of usable space. So let's look at what would happen if I added a 1 terabyte drive to this pool. So then the smallest drive would be 1 terabyte. I'd have 4 drives, so minus 1 for RAID Z1. So that would be 3 times 1, so I'd only have 3 terabytes of usable space. Right, so with the drives assigned, I'm going to click on the name of the pool here. And for file system, I'm going to set this to ZFS. But please note that ZFS encrypted is also an option. This will create encrypted Luke's disks and then have the file system on top. I'm going to use just regular ZFS. So now with ZFS chosen, you can see we've got a few options. Now the first thing is what type of Z pool do we want? Now RAID 0, in my opinion, not a good idea. That stripes the data across all the disks with no redundancy. So you'd only want to do that with something you really just didn't care about at all. So we could choose mirror here, which would then mirror the data across those 3 disks. But what I'm going to do is I'm going to use a RAID Z pool, and what this will do is one of the drives will be parity and the rest data. But it's slightly different than we're used to in Unraid with 1 parity disk, because yes, 1 disk's worth of parity is used up, but the parity is striped across all 3 of the drives. Okay, so once we've decided the type of Z pool that we want, we can then choose whether we want compression or not. And the compression can either be turned on or off. By default, when it's on, it uses the ZFS default compression algorithm LZ4. But in future versions of Unraid, we're going to be able to choose in a GUI additional compression algorithms as well. Now there's a question I hear asked a lot, is does enabling compression slow down the reads and writes on the server? Well, compression can actually speed up data access and writes due to the following reason. There's a reduced disk I/O when data is compressed, because it's taking up less physical space on the disk. For example, if you had some data that was 180 gigs when it wasn't compressed and is say 120 gigs when it is, well, it's physically taking up less space on the disk, so reading and writing this compressed data can significantly speed up the disk I/O. This is especially true on slower mechanical hard drives. However, there are use cases where compression may not be a good idea. If the data is already highly compressed, if we think of things such as H.265 video, the additional compression is not really going to yield any extra space savings, so it may in fact actually slow down the data access and writes because of the time taken to try and compress and decompress the data. And we're not gaining any speed because there isn't any reduced I/O time, because the data was already compressed. So when choosing whether to compress a disk or not, think about what kind of data you're going to be putting on there as to whether you should do so or not, and use what's going to work best for your use case. Anyway, today I'm going to enable the compression. The next setting we can see here is auto trim, which by default is set to on. Auto trim is really when we're using SSDs, so I'm going to set that for off, and enabling user share assignment. Basically, do we want to be able to create shares in this Z pool or not? Most of the times you're probably going to want to. So with that done, I'm going to click on to apply, and done. And so that Z pool's now prepared. So I've got this last disk here, and one thing I think is quite overlooked in Unraid is the fact that you can actually add disks to the existing Unraid array and format that as ZFS as well. Now when we're adding a single ZFS disk, whether to the array or just to a pool, obviously there's no option for what type of Z pool we're creating, because basically it's just a 1 disk pool. And do we want compression? Again, I'm going to set this for yes, but please think about what you're going to put on this disk. If you're going to have movies on there, like I say, don't bother trying to compress things that are already compressed. That's my opinion anyway. And with that done, we can click on to apply. Now, while I'm here, one thing I want to show you, there's been an additional feature added to ButterFS as well. If I click onto the cache drive here, we can see we can also use compression on ButterFS drives now. So that's pretty cool. But one thing I think I should point out, if you select compression to be on an existing ButterFS drive, it's not going to recompress all the data that's already there. It will just compress the new data written going forward. File system auto trim's been added to Btrfs as well. I'll talk more about the difference between file system trim and OS trim when we look at the XFS improvements later on, because it's been added there too. Okay, so I've created those Zpools, so now let's start up the array and format the drives. Okay, so we can see the drives are formatted now. I've got the single ZFS disk in the Unraid array, so now I've got an XFS disk and a ZFS disk. And here's the RAID Z1 Zpools that I created. Now I can see the total size of it is 7.8 terabytes. And now if I click onto the name of the pool here and I scroll down, we can see these three settings at the bottom. We've got the critical disk threshold here, which is set by default to 90, and the warning set to 70. But also we've got this minimum free space setting that by default isn't set to anything. Now when a Zpools reaches around 80% capacity, it can start to suffer from reduced performance due to things like fragmentation. So I think this is why we got the warning at 70 and the critical at 90. Now what I recommend to do is, for the minimum free space, set that to 10%. So what this will mean, the Unraid shares won't be able to write things to this drive unless it's got more than 10% free space. So I think that's like a good safety thing to do. Now scrolling down here, we can scrub the ZFS pool. Now you may have seen the scrub feature on Btrfs pools in the past on Unraid, and what data scrubbing does is basically a proactive, preventative maintenance for the integrity of the data. Think of it like a kind of deep clean or a full health check of the entire Zpools. What the scrub does is check every single piece of data to check it's not corrupted. And it does this by comparing the data to a checksum which was created when the data was first written. And if it finds anything wrong and the pool has redundancy, like it does in my pool here because it's a RAID Z1, then ZFS will automatically repair the corrupted data using the redundant copies. Now scrubs can take quite a long time, especially if the pool's large, and you can set it to automatically run, or you can manually initiate a scrub by clicking on this button. Now it's worth mentioning that ZFS can also repair data reactively as well. So what I mean is ZFS does check data integrity when it normally reads the data just accessing your normal files as you access them, and if there's a problem, the checksum doesn't line up, then it can automatically heal the file system. Now this is one of the great advantages in my opinion of ZFS. So for you guys out there who worry about bit rot, well, ZFS is the perfect file system for you. Now personally, I'm going to leave the schedule disabled, and I'll manually activate a scrub from time to time when I feel fit. Now just scrolling back up here, we can actually turn compression on and off, but we can't do this while the array is started. We'd have to stop the array if we wanted to turn compression off on the pool, and again, it would only affect the data going forward from that point. It wouldn't decompress the data that had already been written. Okay, to see the next improvements in 6.12, let's go across to the Shares tab. Now we can see here, under Storage, we can see Cache and Array, and the arrow is pointing from the array to the cache. Now if I click onto the App Data Share here, we can see now there's a conceptual change in Unraid for how cache pools are used and how the storage is managed. So here we set the primary storage, basically where all new files are written. For my app data it's set to cache, but obviously I could change it to the other pool that I've just created, or I could just have it as the array. So rather than having things like use cache only, prefer and none, we have this option here called secondary storage, which we can set to array or none. And if I set this to none here, we'll notice because it's set to none, we've only got primary storage. So this would have been the same as use cache only in the previous versions of Unraid, because here we can see that mover doesn't do anything. Now if I set the secondary storage back to the array, then the mover action at the moment is set to go from the array to the cache. So what this means is my primary storage is the cache, and only if the cache gets filled up, it will write to the array. And so then what mover would do is it would move those files from the array back to the cache if free space became available on the cache drive. So this would be the same in earlier versions of Unraid when the cache is set to use cache prefer. Now we can set the mover action here to be from cache to array. Now I wouldn't use this for app data, but what this would do is new files would be written to the cache, and then when mover runs, it will move them from the cache onto the array, which is my secondary storage. Now one thing I'd love to see, to be honest, is if the secondary storage could also include other pools. Maybe that's something we'll see in the future. I really hope so. Anyway, I'm going to change this back to the mover action being array to cache and click on to apply. And going back to the shares tab here, we can see now we can view our files by clicking on the view icon, which is now on the left next to the share. So that's much better now, because when it used to be on the right hand side, it was very easy to get confused and click on the wrong thing. So this makes it much easier, I think. Okay, so enough on this server now. Now let's go across onto my main server and have a look there. Okay, so here we are on my main server, and you can see I've got a few more drives here. Now I've got one ZFS drive in my Unraid array. So why do I actually like this? Well, one, I like having compression. Yes, I could have that with a Btrfs drive, but the thing I like about having a ZFS drive in my array is I can use ZFS send to and from the actual main array. And to me that's really useful. So what I can do is I have my app data on a single drive NVMe here. So it's nice and fast being an NVMe drive, but I don't have enough NVMe's to make this a mirror. So what I can do is use ZFS send to replicate it onto disk 5. And because this ZFS disk is inside the main Unraid array, it's protected by the parity of the Unraid array, and should it fail, Unraid would be able to rebuild the missing drive. So my data is protected. Now obviously I'm not going to have the advantage of speed, which we have in a regular Z pool, like this RAID Z1 pool I've got here of these regular SATA SSDs. So having these all together, basically the data is written to and read from all at the same time, so it's really fast. What I'm going to do is I'm going to do a quick test now to show the difference in speed between reading and writing to this Z pool with 3 SATA SSDs compared to writing to this single SATA SSD here, which is an XFS disk. Now talking of XFS, if I click onto this here, there's been an improvement made on XFS in Unraid as well. For single drive pools, we've now got auto trim, which is enabled by default. So that's nice to have. Now you may be wondering just what's the point of auto trim when the actual OS supports trim commands anyway. Well, as of Linux kernel 5.10, XFS now includes built-in support for automatic trim operations. So basically by enabling automatic trim in XFS, it allows the file system to manage trim operations independently. So with this feature enabled, XFS can issue trim commands based on its internal policies, such as when files are deleted or when space is reclaimed, and so theoretically improving the SSD's performance and its lifespan. So definitely worth enabling it. Okay, so let's get back on track and do our speed tests. Now I'm going to go to the Docker tab here, and I've got this container here, and I've mapped it to the Prometheus pool here, which is the Z pool, and to the single drive SATA SSD. Now this is just a simple Debian container with FIO or FIO, I'm not sure how it's pronounced, installed, which allows us to do some various tests. So I'm going to start this up now and open a console window. And first I'm going to test the XFS location. And so this first test I'm going to do is going to simulate the workload of reading, say, video files from this location. Okay, so that test is done. And we can see the results here. And I'm getting a read speed of about 540 megs per second. So that's about the max speed I'm going to get out of a single SATA SSD. Okay, so now I'm going to do the same, but this time on the Z pool. Okay, so the read test, I'm getting a better speed. I'm getting almost double what I was out of the single drive. I'm getting 900 megs per second. Okay, so we all knew that reading from 3 drives is going to be faster. Anyway, the last thing we're going to look at in this video is how to import an existing Z pool that you may have had made elsewhere. Now, I've got a Z pool that I had on TrueNAS, so I'm going to stop the array. Okay, so now the array's stopped. So what I'm going to do now is I'm going to add 4 8TB drives to my Unraid server that used to be in TrueNAS. It's really best practice to actually shut the server down but I know I can hot swap on this machine. Okay, so the hard drives are connected now, and we can see these are from a TrueNAS machine because the drives are actually partitioned. If we quickly take a look at, say, this 12 terabyte drive here, if I unassign it, it will pop down as an unassigned device, which is this one here. We can see that Unraid created Zpools, well, they only have one partition. Anyway, I better pop that back in. So how do we add this existing Zpools? Well, one thing I've got to be careful of is these are all 8 terabyte Toshiba drives, but this one here is an XFS one I record CCTV footage on. So I'm going to be careful not to accidentally add this. Anyway, all we need to do is click onto add pool, give it a name. I'm going to call it Battlestar because that's what it was called before. And there's 4 drives, so I'm going to choose 4 slots and click on to add. Now I just need to assign the drives. So let's quickly have a look at what that CCTV one is. Okay, it's SDI, so I just don't want to assign that. Okay, so that's the 4 correct drives assigned. Now all we have to do is have file system type set to auto, and that's it. And so with that done, all we have to do now is start up the array. And now we can see that pool's been imported. If I click onto it here and scroll down, we can see that it's RAID Z1, and it really is just that easy. Anyway guys, I'm going to wrap up this video here now, and the next video is going to show how to easily convert your existing app data, so each folder is a data set, and then using snapshots on those data sets, so should a container go wrong, it's just really easy to roll back. Anyway guys, it's getting late here, so it's time for me to go, but I really hope you enjoyed the video. If you did, please share it with anyone who you think will find it interesting, and if you liked it, well, hit the like button. As all YouTubers say, it helps the algorithm, apparently. Anyway guys, it's getting late here and it's time for me to go, but whatever you're up to for the rest of the day, I hope it's good, and I'll catch you in that next video.